All right, so today's notes are on the quadratic formula. Our content objective is to solve equations using the quadratic formula and determine the number of solutions by using the discriminant. And our language objective is to use the correct terminology to explain the quadratic formula and discriminant. So first thing, quadratic formula, what is it? It's a formula used to solve for x-intercepts of a quadratic. And it's derived by completing the square from standard form. I'll give you guys bonus points for doing this on your own. So if you want to try completing the square from standard form, be my guest. You should end up with the quadratic formula. If you want help with this, I can help you, but bonus points if you try it out. So it's the actual formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is where we plug in a, b, and c are the same a, b, and c we've been working with since we started factoring. And this is the formula. All you have to do is substitute everything and then simplify correctly, which can sometimes be easier said than done. So let's jump in with an example. Our first one, asks us to solve 2x squared minus x equals 4. So first step, we want to rearrange into standard form. So if you don't know what standard form is, it's ax squared plus bx plus c. So we want to get our c value onto the other side. So we're going to subtract that from both sides. You get 2x squared minus x minus 4 equals 0. So we rearrange into standard form. And then step 2, we're going to identify a, b, and c. Also, it needs to be set equal to 0. I don't know that I made that clear initially. When I say standard form, I mean also equals 0. So it needs to be set equal to 0. Identify a, b, and c. So we know a is 2, b is -1, and c is -4. So we have a, b, and c values. Now all we're going to do is substitute and simplify. So when I do that, I'm going to say x equals -1. So make sure when you plug in, you account for the negative that's in front, plus or minus the square root of -1 squared minus 4 times 2 times -4. Notice that I'm plugging everything in parentheses because it's going to be easier to keep track of negative and positive values if it's in parentheses. And that's all going to be over 2 times a, which is 2. So 2 times 2. Now I'm just simplifying this. So I have x equals -1 becomes +1 plus or minus the square root. -1 squared is just 1. -4 times 2 is -8. -8 times -4 is +32. So 4 times 4 is 16, times 2 is 32, negative times negative is positive. However you want to do that mental math in your head, but -4 times 2 times -4 ends up at +32. And that's all over 2a, so 2 times 2, which is 4. Got to keep going. We're not fully simplified yet. So I have 1 plus or minus the square root of 33 over 4. At this point, I cannot simplify this anymore. So this is plus or minus. There's no perfect squares that go into 33. Sorry. No perfect squares that go into 33. And there's nothing I can take out and simplify here, so I'm going to stop at that point. You could plug this into a calculator and get a decimal value, but it depends on the context of the problem. Oftentimes you are fine leaving it in this form unless it needs a decimal answer. But there we go. We're all done. So make sure I did any questions, comments, concerns on that. I'm going to flip the page for a quick check. So I'm going to flip the page. You can send me an email and let me know that you're listening to these notes. That would be helpful. So send me a quick email. Let me know that you're listening. Getting the quadratic formula stuff down. All right. I want you to try to solve this using the quadratic formula. I know you can solve it without the quadratic formula, but I want you to try solving with it. So use the quadratic formula to solve this. Try it out. I'm going to go over it now. It's already in standard form. So I just need to identify A, B, and C. So again, I would actually normally recommend you solve this the most efficient way, which would be factoring or completing the square because it's a perfect square trinomial. But regardless, we're going to move on. Trying this with quadratic formula. So I get x equals negative b, so negative 6, plus or minus the square root of 6 squared minus 4 times 1 times 9, all over 2 times 1. So if I simplify this, I'm going to go this way with my simplifying. So I get negative 6 plus or minus the square root of 36 minus 36, because negative 4 times 1 times 9 is negative 36, all over 2. That ends up with just negative 6 plus or minus the square root of 0 over 2. Square root of 0 is just 0. So you end up with x equals negative 6 over 2, which is just x equals negative 3. So our answer would just be x equals negative 3. The reason I gave us this as the quick check is because it's actually telling us something about our graph, which we can get from our discriminant or the part under the square root. So if you notice the part under the square root, the discriminant ended up equaling 0 or being equal to 0, and then we only had one x value. So let's jump in and figure out why that is. So our discriminant, as I just mentioned, discriminant is the part of the quadratic formula under the radical. So that's going to be discriminant is equal to b squared minus 4ac, because it's just the part that's under the square root, so b squared minus 4ac. And there are three situations that our discriminant can, or three situations that we can have with our discriminant. So b squared minus 4ac, our discriminant could be greater than 0. I'm going to make a little table with these values, so I'm just going to have about 3 lines. Bear with me. So our three options are, our discriminant is more than 0, it's positive. It could be equal to 0, so just is equal to 0, or it could be less than 0. So greater than, equal to, or less than, which would mean it is negative. If it is positive, we end up with two real solutions. So two real solutions if it's positive, which means if we had a quadratic, there would be two x-intercepts. So it could look like either of these parabolas. So we'll have two x-intercepts. So if our discriminant is positive, then we can take the square root. So the discriminant is the part under the square root. If we have a positive, we can take a square root. There's no problem. We end up with two answers. That's like what we practiced in our original example. So that's completely fine. If it's equal to 0, just like we saw here, we end up with one real solution. So that was like our quick check right now. We saw that we got one real solution. In that situation, that means that our vertex, which we'll talk more about when we learn more about the graphing part, that means we only have one x-intercept, it's at our vertex. So one x-intercept if our discriminant is equal to 0. So if our discriminant is equal to 0, we get one x-intercept. It only hits the x-axis one time. Our last example, if it's less than 0, we can't take the square root of a negative number. So we can't take the square root of a negative discriminant. So we end up with no real solutions. We'll end up with complex or imaginary solutions, but we'll talk about those later. But what that ultimately means is we have no x-intercepts. So our graph is entirely above or below the x-axis. we have no x-intercepts when our discriminant is negative. So those are 3 situations that you need to pay attention to. For discriminant is positive, equal to 0, or negative, you either end up with 2, 1, or none for x-intercepts. So quick check. Last thing. How many real solutions are there for the equation negative 2x squared minus 3x plus 5 equals 0? So try it out. I'm going to go over it now. So all you need to do here is identify A, B, and C. So A is going to be negative 2, B is negative 3, and C is positive 5. I don't need to use my whole quadratic formula. I just need to use the discriminant, so b squared minus 4ac. So I'm going to say, I'll write this here. So I have negative 3 squared minus 4 times negative 2 times 5. I'm going to simplify that. So I get negative 3 squared is positive 9 minus 4 times negative 2 is 8. Positive 8, 8 times 5 is 40. So I end up with plus 40 because negative times negative is positive. So that is equal to 49. So I end up with 2 real solutions. So I get 2 real solutions. That will be my answer. That's the number of real solutions for this equation. And that's all for today. Make sure you write down any questions, comments, or concerns on this so we can go over it together in